This problem uses scikit-learn's output code classifier to handle a classification task with 5 distinct categories, numbered 0 to 4. The model employs multiple binary classifiers, working together to make predictions for each class. The core of this quiz is a set of predicted probabilities. For a single data point, the model generated probabilities for each of the 5 classes. Note that each class has 2 probabilities because 2 binary classifiers contributed to the prediction. This refers to the 5 different classes, 0, 1, 2, 3, and 4. The model is trying to predict. This column represents the prediction from the first of the 2 internal binary classifiers for each class. These are probabilities of belonging to a particular class. This represents the prediction of the second binary classifier for each class. Each value represents the prediction of one of the 5 possible classes. This indicates that the following probability is associated with class 0. This is the probability assigned to class 0 by the first binary classifier. It is a high probability. This signifies the predictions for class 1. This is the probability of class 1 from the first classifier. This is the probability of class 1 from the second classifier. This shows the beginning of predictions for class 2. Probability of class 2 given by the first classifier. Probability of class 2 given by the second classifier. This indicates the start of class 3 predictions. Probability of class 3 from the first classifier. Probability of class 3 from the second classifier. This denotes the start of the predictions for class 4. Probability of class 4 from the first classifier. Probability of class 4 from the second classifier. This is one of the multiple choice options for the predicted class label. This is another option for the predicted class label. This refers to the single data point for which we're predicting the class label. It's the input to our model. Think of it as one row of data in our dataset. It's the single instance we are evaluating. This shows the predicted probability for class 0 from one of the binary classifiers used within the output code classifier. The probability is 0.9. Meaning there's a 90% chance it belongs to class 0 according to this particular classifier. We will average these probabilities later. It is very high. Here, we have 2 probabilities for class 1, one from each of the 2 internal binary classifiers. One classifier gives a low probability, 0.1, while the other gives a higher probability, 0.8. We'll average these values. Similarly, class 2 has 2 probabilities, 0.2 and 0.7, from 2 classifiers. The concept of averaging will apply again here. Same situation as class 1 and class 2. 2 probabilities for class 3 to 0.3 and 0.6 from the 2 binary classifiers. We will take their average. Finally, we have 2 probabilities for class 4 to 0.4 and 0.5. They represent the predictions from each of the 2 binary classifiers used in 1V's REST strategy. The averaging applies here as well. This explains that the model employs a 1V's REST strategy. In this strategy, multiple binary classifiers are used. Each classifier is trained to distinguish one class from the rest of the classes. In this case, we have 5 classes, 0 to 4. Thus 5 binary classifiers are trained. Output code classifier uses this strategy internally. This indicates the method used to combine the predictions from the multiple binary classifiers. A simple average, sum of probabilities divided by the number of classifiers, is used to obtain a single probability for each class. These are the probabilities obtained after averaging for each class. These will then be used to determine the predicted class label. This is the final output of the model, the class to which the data point is assigned. It's the class with the highest average probability. Okay, Vamsi, let's start with the input. We're given predicted probabilities for a single data point across 5 classes, 0 to 4. Each class has 2 probabilities because 2 binary classifiers were used internally. It's like having 2 votes for each class. For class 0, the first classifier gave a probability of 0.9. This is a very high confidence prediction for class 0 from that classifier. For class 1, the first classifier is less confident, 0.1, while the second classifier shows much higher confidence, 0.8. This suggests some disagreement between the 2 classifiers. Similarly, for class 2, we see a lower confidence, 0.2, from the first classifier, and a higher confidence, 0.7, from the second. Class 3 also shows some difference in confidence between the two classifiers, 0.3 and 0.6. And finally, Class 4 has relatively similar confidence scores, 0.4 and 0.5, from both classifiers. Now, we need to average the predictions for each class. This is because we're using a simple average to combine the classifier outputs for output code classifier. The average for class 0 is simply 0.9, as there's only one probability given. For class 1, we add the two probabilities, 0.1 plus 0.8 equals 0.9, and divide by 2 to get an average of 0.45. The average for class 2 is calculated the same way, 0.2 plus 0.7, 2 equals 0.45. Class 3 also has an average of 0.3 plus 0.6, 2 equals 0.45. And the average probability for class 4 is 0.4 plus 0.5, 2 equals 0.45. Now it's time to find the class with the highest average probability. This will be our prediction. As you can clearly see, class 0 has the highest average probability, 0.9, significantly higher than the 0.45 for other classes. Therefore, the output code classifier predicts class 0. The problem describes a multi-class classification task using scikit-learn's OutputCodeClassifier. We're given predicted probabilities for 5 classes, 0 to 4, from 2 internal binary classifiers. The goal is to determine the predicted class label by averaging the probabilities from the 2 classifiers for each class and selecting the class with the highest average probability. Let's dive in. The problem describes a multi-class classification task using scikit-learn's OutputCodeClassifier. We're given predicted probabilities for 5 classes, 0 to 4, from 2 internal binary classifiers. The goal is to determine the predicted class label by averaging the probabilities from the 2 classifiers for each class and selecting the class with the highest average probability. Let's dive in. This row presents the predicted probabilities for each of the 5 classes. Notice that each class has 2 probabilities because 2 binary classifiers are used internally within OutputCodeClassifier. For example, Class 1 has probabilities 0.1 and 0.8 from the 2 classifiers, respectively. It is an important data to solve this problem. This row presents the predicted probabilities for each of the 5 classes. Notice that each class has 2 probabilities because 2 binary classifiers are used internally within OutputCodeClassifier. For example, Class 1 has probabilities 0.1 and 0.8 from the 2 classifiers, respectively. It is an important data to solve this problem. Here, the average probabilities for each class are calculated. For instance, the average probability for Class 1 is 0.1 plus 0.8, 2 equals 0.45. This step is crucial because the question states that the prediction uses a simple average of the probabilities from the internal binary classifiers. It's like taking a simple average of your exam scores. Here, the average probabilities for each class are calculated. For instance, the average probability for Class 1 is 0.1 plus 0.8, 2 equals 0.45. This step is crucial because the question states that the prediction uses a simple average of the probabilities from the internal binary classifiers. It's like taking a simple average of your exam scores. This is the final answer. By comparing the average probabilities calculated in the previous step, we see that Class 0 has the highest average probability, 0.9. Therefore, the OutputCodeClassifier predicts Class 0 for this data point. We've cracked the code. This is the final answer. By comparing the average probabilities calculated in the previous step, we see that Class 0 has the highest average probability, 0.9. Therefore, the OutputCodeClassifier predicts Class 0 for this data point. We've cracked the code. These are the multiple choice options provided for the quiz question. Option A, 0, is the correct answer, as explained above. Options B, C, and D are incorrect because their average probabilities are lower than that of class 0. It's always nice to get the right answer. These are the multiple choice options provided for the quiz question. Option A, 0, is the correct answer, as explained above. Options B, C, and D are incorrect because their average probabilities are lower than that of class 0. It's always nice to get the right answer. This row shows the predicted probabilities for each class. Each class has two probabilities because we're using two binary classifiers internally. This is a key piece of information needed to answer the question. These are the actual probabilities given by the two binary classifiers for each of the 5 classes, 0 through 4. Notice that each class has two probability values. We need to average these to get a single probability for each class. This step involves calculating the average probability for each class by summing the probabilities from the two binary classifiers and dividing by 2. This is a crucial step in solving the problem because it tells us the most likely class. Here are the results after calculating the average probabilities for each class. For example, the average for class 1 is 0.1 plus 0.8, 2 equals 0.45. This represents the combined confidence of both classifiers for each class. After averaging, we choose the class with the highest average probability. This is because it represents the class most likely to be correct based on the combined predictions of the binary classifiers. This is the final answer. Class 0 has the highest average probability, 0.9, so the output code classifier predicts class 0 for this data point. This refers to the single data point for which we are predicting a class label. It's the input to the output code classifier. Think of it as one specific example that we feed into our model. We'll use the model's output for this single example to make our prediction. For class 1, two internal binary classifiers provide probabilities. The first one gives a probability of 0.1, while the second one gives 0.8. These are the intermediate outputs before we combine them. We are given individual probabilities from two different classifiers for each class because the output code classifier uses a 1v's rest strategy, which means each class is compared against all others in separate binary classification tasks. Similarly to class 1, class 2 also has two probabilities, 0.2 and 0.7, from the two internal classifiers. Notice the pattern. Each class has two predictions. This is a crucial detail for the averaging step. Here are the probabilities for class 3 from our two binary classifiers. It's important to keep track of which probability came from which classifier, as the problem asks us to average them. The last class, class 4, also has its pair of probabilities, 0.4 and 0.5. These probabilities, along with those of the other classes, allow us to calculate the average probabilities for each class, helping to determine the most likely class.